Hi everybody, this is our activity on heat movement. In our previous activity on room temperature, we found out that things really don't like to be different temperatures. In our sim, if we mix two things, the temperatures would really move around until both of the things became the same temperature. And today what we want to do is see if that temperature has a specific way that it wants to move, and it actually does. And we're going to learn something that sounds really fancy. It's just called it's the second law of thermodynamics, which is actually something that is pretty simple. Anyway, here's the setup we have. Once again, we have our single thermometer right here. We're going to be making a graph. Now that thermometer is hooked up to this little setup right there, and the thermometer is on this metal bar, and the thermometer is right between them. And you can see I've got this labeled cold and hot. Metal is a weird thing when it comes to temperature, because all of you know that if it's a cold day and you're outside and you touch something metal, it feels real cold. It feels a lot colder than, say, the pavement or grass or something like that. But in the summertime, it's just the opposite. It feels warmer than everything. So if it's warm out, the metal feels very warm, but if it's cold out, it feels very cold. What we're going to do on this is we're going to give metal a kind of a chance to be hot or cold at the same time. So what we're going to do is I'm going to fill this side up with some ice water, which is about 0 degrees Celsius, and I'm going to fill this side up with some 20 degrees Celsius water, a little bit warmer than 20, and we're going to see if this changes. Maybe they equalize out and nothing happens, but we want to see what this bar does. If this bar gets warm, it's going to suggest that the hot wants to move over to here. And if it gets cold, it's going to suggest that the cold wants to move here. And when we mix them in room temperature, basically, you know, we know that when we put a hot and a cold item together, the hot would get cooler and the cold would get warmer. But is the cold giving its cold to the hot, or is the hot giving its cold, giving its heat rather to the cold? That's what we're hopefully going to see with this. Now I'm going to go ahead and start our data collection here. And again, you can see that is about 22 degrees Celsius. Our red bar is going to come out there. And I'm going to go ahead and now pour our hot and cold water into these. And we'll see what kind of change we get. Trying to get about the same amount of water in each one. And that's pretty good right there. So we've gone ahead and mixed those, and now we're kind of seeing where that's going. And if we go back to the screen here, we can see that temperature is definitely spiking upward. So the middle of that bar, given a chance to be hot or cold, really is definitely choosing, I want to get warm. We'll watch that for a little bit, but that's a pretty clear trend right there. Now remember, the thing that was hot and cold is the water. And we're going to be off of this real quick. So at any rate, you can definitely see, we can see that the middle of that bar got pretty substantially warmer, spiking up pretty good. I'm going to go ahead and stop this. We're going to go back here. And so the middle of that bar, now the thing that's hot or cold is the water. So somehow that hot in the water got into this somehow, which we'll find out at a later time. And the hot kind of went this way trying to get over to here. Now remember, in Amplify, when we're mixing things, they always get to the same temperature, and you see the cold thing heat up and the hot thing cool off. And then the question again is the cold cooling off the hot, or is the hot cooling off the cold? This certainly is suggesting that the hot is heating up the cold, because this got hot right here. It goes to figure that it's getting hot over here too, and that hot's heading right down in here. So this is kind of like, or the bar is kind of like our heat or cold highway. If this would have dropped in temperature, then we would have thought, well, whatever cold is going into the hot and cooling it off. And that's it for today's demonstration. Thanks for watching.